This is Yuanlin Zhang from Texas Tech University. Today, I will present an integrated approach to data science foundations in computing, mathematics, and statistics. It's a joint work with Han Xiang, Wendy, Wanli, and Joshua. The theoretical framework for the integrated approach will be presented after a quick introduction. To test the feasibility of the framework, we carried out experiment, and we will present the results and the conclusion of the experiments. Data science has demonstrated its importance in science and industry. There is a strong demand of workforce fluent in data science. As a result, the data science course will be beneficial to students on both of their academic life and future career. By a report of the National Academy, data science has its foundations in computing, mathematics, and statistics, among others. The challenge is how to teach and learn these seemingly different foundations. We propose a theoretical framework to seamlessly and coherently integrate these foundations. The intuition of the theoretical framework is that the data in data science in general are sets of interesting objects and their relations in human activities. Data science offers means to represent and reason with the data. Set theory and the logic of mathematical logic provide a language for representing and reasoning with the sets and the relations, forming a base for integrating the foundations of data science. Abstraction is at the core of computing. Logic allows us to have an explicit definition and of abstraction, which consists of these four components: problems, language, abstract, and methodology. Questions are clearly at the core of any problem, and we use the set theory and the logic as the language. And to abstract is to really represent, using this language, the information relevant to the questions of the problem. And the methodologies for abstraction is really problem decomposition and iterative refinement, among others. Here is an illustration of this theoretical framework. Data science involves foundations in mathematics, statistics, and computing. And abstraction and programming are at the core of computing. To solve a problem using a computer, one way is to directly apply this abstraction and then the programming. Alternatively, we further resort to math concepts and or statistical concepts to develop the final computer models. For learning purposes, one can see abstraction can be used for students to understand math concepts and statistics concepts. And the math concepts and statistics concepts can really provide opportunities for students to practice their understanding of abstraction. Similar relationships exist among math concepts, statistics concepts, and programming. That's the framework. So in our experiment, we developed an 8-week curriculum. We implemented in an elective course named Computer Science 2 at a public school in Texas, a public high school. We collected data using pre-post tests, surveys, and interviews. The curriculum consists of several modules. In the first 2 weeks, we introduce abstraction. And in the next 1.5 weeks, we introduce programming. Using the abstraction and programming, we're able to introduce the basics of statistics and the central tendency of statistics in the next 2 weeks. And we use the last 2.5 weeks, we introduce the concepts of 2 category variables and 2 quantitative variables. Here is the demographics of our participants. And for the measurements, we used 13 questions on statistics and programming. In our tests, these questions are either multiple choice questions or short answer questions. We also did in-class interviews based on exercise questions. We also carried out end-of-class group interviews on students' opinions, comments about this course. Here is a quick example of the test questions. In this example, we try to understand, we try to check a student's understanding of sets, the definition of functions, and the use of functions. Here are the results about the pre-post tests on all questions, including both statistics and computing. So students has before in the pre-test they got about 10 points, and after that they got 28 points. And this is the results, particularly about the statistics questions. It's out of 43 points total, and the mean of the score is about 1, and the post test is 8. So here are the results of our interviews. In terms of the course complexity and the content, 4 students thought the content is easy to understand and they can see the connections of the components. At the same time, we did note that there are 2 students who still felt shaky about the content and the connections of the components. Here is some result about students' comments on the impacts of learning statistical concepts on each other. At least 6 students identify the benefits of learning statistics and computing at the same time, and they can see the positive impacts of the learning on each other. So we did have other comments such as these modules really help them to bridge the gap between school education with the industry. The pre-post test scores shows a significant improvement of students' understanding of statistics and computing from the interviews. Most of the interviewees thought statistics and computing are well integrated, and they can see the impact of statistics and computing on their learning. In summary, experiment results are positive in showing the feasibility of our framework to integrate data science foundations in computing, mathematics, and statistics. Thank you.